In this video, we're going to combine what we know about counting principle with what we know about probability to answer a couple questions. Our first one involves one of my favorite foods, pizza. So pizzas can be ordered in 3 different sizes with 3 different types of crusts, 4 different types of sauces, and 10 different toppings. The first question is, well, how many different one-topping pizzas can be ordered? Well, our counting principle says you look at all your different categories, figure out how many options for each, and then you multiply those all together. So for us, we have size, crust, sauce, and toppings. Those are the 4 different categories. And I have 3 sizes, 3 crusts, 4 sauces, 10 toppings, multiplied all together tells me we could come up with 360 different one-topping pizzas. All right, so that's the total number of one-topping pizzas. The next question is, what is the probability a one-topping pizza ordered is a small pizza? Okay, so I know the total number of one-topping pizzas, 360, but what about the probability that what I've ordered is a one-topping small pizza? Well, probability, you recall, is number of favorable outcomes, what we're looking for, divided by the total number of outcomes. So for us, we have the total 360. How are we going to calculate the number of favorable? Well, the only thing that has changed is right here on the size. We're now restricting it to one choice. We want a small, but we can still have 3 different kinds of crusts, 4 different kinds of sauces, 10 different kinds of toppings. So we're going to get 120 different small pizzas divided by the 360 total, or a 1/3 probability that the pizza ordered is a small. That kind of makes sense, right? Because if there's 3 choices, then probably 1/3 of them are smalls. Let's take a look at another one. This one involves radio station call letters. So I don't know what your favorite station is, but it probably, if it's on broadcasting from the Missouri side, will start with a K, because all stations to the west of the Mississippi have call names that start with a K. To the east of the Mississippi, they'll start with a W. So we want to know how many different radio stations we can have that start with W or K. So we have 4 different letters. The only restriction is that first one that is a W or K. So there's only 2 choices there. Otherwise, any letter works. Well, we know there are 26 letters in the alphabet. So 2 times 26 times 26 times 26 is a whopping 31,152 different combinations. Okay, next question. Let's bring in the probability here. What's the probability that a station name ends in a vowel? Well, just like before, probability is number of favorable divided by total. We have the total, so you just have to figure out how to count up the number of favorable ending in a vowel. If you think you've kind of got what's going on here, hit pause and see what you can come up with. Okay, let's take a look. So for this one, my bottom is still going to be the 2 times 26 times 26 times 26. But on the top, it's going to be 2 times 26 times 26, because I don't care about those first letters. It's W or K, and then whatever letter. It's the last one, a vowel. A, E, I, O, U, for the normal vowels. So that's 5 options for that last letter. That's the only thing that changes. Now you notice I wrote out, rather than using that 31,000 number at the bottom, I wrote out how I was calculating the answer for the bottom, because that allowed me to quickly cancel things and get to an answer. So sometimes it's easier to start from the beginning on these problems than it is to start with that total number that you came up with up here. If you're using a calculator, it's going to be the same either way. Probably just as fast, but I want to show you some mathematical shortcuts when I can. Let me know if you have any questions.